Brazil, and we are undergoing research about meteors. Well, usually meteor with hyperbolic orbit types are found in many meteor surveillance database, and the main question are 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 real hyperbolic orbits? One moment. Are there real hyperbolic orbital meteors? If so, a set of them could be from the outer solar system. The answers seem to be inconclusive from the works of Hadjukova, many works from her, that demonstrated that meteors with hyperbolic orbits are mainly due to inaccurate velocity measurements. And but after the discovery of two objects, interstellar objects, Oumuamua and Borisov, this discussion was renewed. And to try to respond to this question, we followed the methods of Hadjukova, and 3-meter orbit data sets from Edemont, Sonotaku, Ixos were analyzed. Well, let's talk very quickly about those two interstellar objects, Oumuamua and Borisov. Oumuamua is a very peculiar object with a shape, a cylindrical shape. As you can see in the right side, the graph, it's showing the path that is very high, from a very high inclination, very different from what it's expected from Oort cloud comets going from there of our solar system. But it showed a non-gravitational effect. So probably he has a kind of activity, a kind of outgassing effects around 0.4 kilos per second, perhaps. About Borisov, it's an atypical comet with activity, and is peculiar because the ratio of carbon monoxide to water is a very higher than where it is expected from comets of our solar system. And but he is very similar to the native solar system's comet. Well, so inspired from those two objects, we go through the database of Edemont, Sonotaku, and Ixos, a total around 500,000 orbits. And after applying quality criteria, we obtained 187,000 orbits, and a subset of hyperbolic orbits, total of 13,000 more or less hyperbolic orbits with high quality measurements. And you see in this, the right side of the table, you can see our main results after the statistical approach. And you see that the main result is that from the total of good and high quality orbits, we obtain more or less 4% of hyperbolic meteors. From Edemont, 1.7%, or more or less 2%. From Sonotaku, more or less 6%. And Ixos, more or less 4% of hyperbolic meteors from the 187,000 all quality orbits. So, well, we have in this question problems of measurements. That is the main problem. And we did those diagrams. They are angular angulation of the apparent radiant from the apex plotted against the non-atmospheric velocity of meteors. And you can see meteors are distributed in a very narrow zone of the diagram, where the possibility of the discriminating between orbits of different semi-major axes is most demanding. It's clear that the large semi-major axis, the valor, is strongly affected by any small error of measured speed or radian position. So you see the hyperbolic are in orange crosses and elliptical orbits are in the blue dots. And you see the hyperbolic orbits is following the mainstream that it is expected. And you see in the right side, more going to the bottom, is where are localized the meteor shower, and you have a more hyperbolic meteor orbits. Of course, they are not true hyperbolic. They are from measurements error. Well, after that, we were able to get more or less 114 possible hyperbolic meteors, true or false, because they are greater than 46 kilometers per second heliocentric velocity that is expected for an interstellar object, considering an average of interstellar velocity of 20 kilometers per second. But more analysis has to be done for inclination, beginning heights, and for more parameters to really separate what is true and what is false hyperbolic, and then again do a more accurate analysis, separate what is which one of them are real interstellar. Well, in the side of the right side, we show a graph showing the distribution of heliocentric velocities, and you can see that follows. Hello, sorry. We can see that it
just
follows.
2 minutes.
Okay, thank you. Follows the kind of Gaussian distribution around parabolic limits of 42.14 kilometers per second that it is expected. Okay, in the right side we have a sporadic meteor orbits that probably there are some real hyperbolic meteors. So finally, our conclusion is that we got 114 possible hyperbolic meteors, and we know now that there are hyperbolic objects passing by solar system. So we need improvement on detections as pixel resolution, back velocity determination, and so on. Thank you all for this very quick presentation. And now I'm going to try to put my video on. I don't know why, but let's see.
All right, thank you very much. A real clap, a virtual clap. You can give him a heart if you like.
Yeah, hi.
Hi, Marcelo.
Can you see me?
Yes, yes, you are here.
Oh yeah,
raised hand.
My question?
Yes, go ahead.
Yeah, Marcelo, hello, fine. Just one question. You mentioned the unit kilometers/sec, S-E-G. Does this mean seconds? Kilometer per seconds?
Yeah, that was just a typo.
One moment, let me see the
slide. Slide from the end. One back. There.
Yeah.
Oh yeah, per second, sorry. Slash
okay.
second.
So
okay,
we ignore the...
It's in Portuguese, sorry.
Okay.
All right, Suresh raised his hand. Is it for real?
Okay.
Aha, that was previous.
Okay, sorry, so please unraise, yeah. Any further question? my very naive question, maybe there was an answer in the talk, but what is the current recorder for the highest, the speediest meteor ever observed, or the highest velocity for a meteor in Earth's atmosphere? Has ever been seen something, you know, like 200 kilometers per second or anything like that?
200 kilometers per second?
Yeah, yeah.
No, I haven't seen yet.
Nothing like that. Because
more or less the velocity, what?
Oumuamua speed.
More or less the average is between 14, 18, the maximum 18 kilometers per second.
What is the most outlier has ever been? Because if you expect real interstellar ones with very great speed velocity excesses, I'm just curious about the observations. Is there any outlier? Has ever been reported anything like above 100?
I don't know, really, I don't know. But you should see that depends on the entry angle, the zenithal angle. It's another variable that you must consider it. So sometimes you have a less geocentric velocity, but a high heliocentric velocity. I think the main point is that you have to measure high heliocentric velocity, very high, very above the limit, the parabolic limit, that is 42 kilometers, or higher than 46.6 kilometers per second. The Borisov comet has an heliocentric excess of velocity of 32 kilometers per second. So it's very, very high. So it's expected really to get hyperbolic meteors very high, the limit, the upper limit, let's say, of 46.6 kilometers per second, maybe 50 kilometers per second, 6 kilometers per second of heliocentric velocity.
Okay. I just remembered an article I read by Avi Loeb, who is very well known for his science fiction articles about a proposed network for observing very fast meteorites in the Earth's atmosphere to probe
if you allow me, if you allowed me, I know that Peter Gurau and Dennis Vida, they are developing a system for higher velocity meteors, and Dennis Vida has published a paper just about more accurate high velocities. This is a really crucial point to make very precisely velocity measurements.
All right. Thank you. It's clear. Okay. Thank you. And anyone else with further comment, question? Then let's thank Marcelo again.